Okay, so in this video we're going to take a look at function transformations, specifically translations or shifts in the horizontal or vertical direction. So transformations are all about taking some function, some parent, we'll call it f of x, and from that parent building a new function, maybe a child of that parent. So something that's going to look like the parent, but it's going to be transformed in some way. So with function transformations, we have some new function, some child, g of x, where it's built from the parent. So if f of x is the parent, then there's going to be an f of x in the child too. But there are also going to be all these extra little numbers, a, b, c, and d. Okay? And all of those little numbers have a job. We're going to focus on the c and the d because those are the translating numbers. C will move my function left or right, and it will always go opposite. Whereas D will transform my function by moving it up or down. So let's suppose we have the function f of x, and f of x looks something like this picture, and we can graph f of x by taking these four coordinates and connecting them. So this is my function f of x. Let's say I created a new function. I wrote a new function g of x, which is equal to f of x minus 2. This minus 2, because it's at the end of the function, after the f of x. This is my d. And you'll remember that we said the d moves the function up or down. So this minus 2 is going to move my function down. It's going to translate it down 2 units. What's that going to look like? That would be me taking every single point and changing the y value by dropping it 2. So in other words, taking my original function and leaving the x's all where they were at, but taking all of my y's and dropping them down 2. So the 0 would go down to negative 2, the 2 would go to 0, the 2 would go to 0, and the 3 would go to negative 1. So that if I were to graph this function, I'm just going to use open circles just so that you can clearly see what it looks like. I would end up with something that looks identical to the parent, but is just all down 2 units. Because that's what that minus 2 does. It translates the whole function down, picks it up and moves it down 2 units. Okay? Now, let's add something along this line. H of x, new child function, which is equal to f of x plus 1 minus 4. This again is a child of this f of x function. Now in this case, the minus d, the minus 4 is my d, so that's going to tell me to translate down 4. The plus 1 is my c. That's going to tell me to translate, and here's where it gets a little tricky, left 1. I know it's positive 1, but remember what we said earlier about the c? We always go opposite. So even though it's plus 1, we're going to translate to the left. So what that means is, if I were to look at my parent points again, and then I were to look at my child points, well, the minus 1 is going to move all of my x's left 1. The down 4 is going to move all my y's down 4. So from here to here, negative 5, negative 3, 0, 2, negative 4, negative 2, negative 2, negative 3. Uh-oh. So I'm just noticing all the way from the beginning that this should have been a 3, 0. This should have been a 3, -2. And this should be now a -4. I graphed the points correctly, but I wasn't labeling them correctly. Now, I'll graph my new points compared to my old parent function. So I'm going to go -4. I'm just drawing my old parent function first. So that is f of x. Now let me go ahead and graph h of x. So -5, -4, -3, -2, 0, -2, 2, -4. So this is my h of x. So when I compare f of x to h of x, I have moved my function left 1 and down 4. And that's what these values told me to do.